Hi everyone, welcome back to GridPro. In this video, we'll pick up from the previous tutorial where we created the blocking for the axisymmetric region of the high-speed wind tunnel. Today, we'll focus on generating the blocking for the showerhead assembly region. We'll use GridPro's hole topology feature to create the topology for the holes, extend the topology to the outer cylinder, and then merge it with the existing axisymmetric topology. Let's create the topology for the holes using GridPro's hole topology feature. It can be accessed through the topology tools, Holes. We will select the two-sided holes, which makes it easier to extend the topology on both sides of the hole. The hole topology dialog box needs to provide the top surface, the bottom surface, and the hole surface group as an input. We have already grouped the surface of the inner cylinder of the showerhead assembly in surface group S1. The surfaces of holes in surface group S2, and the surfaces of the outer cylinder of the assembly in surface group S3. Input the surface groups in respective fields. It is recommended to use the topology type as four-sided plus bidirectional. We want to link the hole topologies along the circular as well as linear manner. Click on Link Holes and look for the pattern which fits our needs. The preview is shown in the purple color. If no existing pattern links the holes in the desired fashion, you can manually select the hole centers in the Edit Pattern group. This stores the previewed corners in the selected corner group. We can link the corners in the desired linking pattern. It is highly recommended to enable the Delete pattern in corner group option. This removes the temporary linking pattern used during hole topology creation, helping prevent any disjointed topology. Add the peripheral faces to corner group C9 to store the outer faces of the hole topology, and then click Apply. This creates topology for the holes. We can link the corner sheets of the hole topology to create a one-to-one connected blocking. Start by retaining the inner set of corners and linking the corresponding corner sheets. Repeat the process for the outer set of corners. Alternatively, this can be done more efficiently by linking the pattern in a linear direction in addition to the circular one, which automatically generates a one-to-one linked hole topology. Now let's create the blocking for the core of the showerhead assembly. First, group the peripheral corners into a single corner group and retain only the innermost corners needed for the core. Next, create a cross-sectional sheet to define the topology of the core. This sheet will later be copied across other cross-sections. Link the necessary corners and add inserts to create the internal wireframe structure. Include any additional corners required and connect them using inserts. This setup helps in achieving a low skew topology for the core. Once the core structure is complete, copy it to the other cross sections and link with the inner corners to maintain one-to-one connectivity throughout the core region. Linking can be simplified by grouping only the corners needed for linking. Group corners of the inner most sheet in one corner group and the outer corners of the core in another corner group. With the showerhead topology complete, the next step is to extend it to cover the remaining domains. Start by grouping the core corners into a single corner group. Next, copy these corners to the inlet surface of the pipe. Similarly, copy the corners from the opposite end of the showerhead cylinder to the corresponding outlet surface. Group the outer peripheral corners and copy them to the cylinder surface. Alternatively, you can use the boundary wrap tool followed by surface alignment for more accurate positioning of the corners. Next, select the sheet near the flat surface of the cylindrical domain and copy it onto the surface. Next, we'll link the showerhead region topology with the previously created axisymmetric region topology. Group the sheets to be linked. Ensure that the corner structure and the number of corners match. Link the corners to complete the topology for the wind tunnel. Finally, delete the earlier created plane to which the corner sheet of the axisymmetric topology was assigned. Assignment part can be done easily using the generic option which highlights the non-assigned corner sheets. Make the respective surfaces as current as assign the corners to the surface by clicking on the Assign Multiple Corners to Current Surface button. The validity check confirms that the topology is valid with no singularities. The topology consists of 4,684 blocks. Before running the grid smoother, density balance should be performed. Turn on the preview and adjust the densities to ensure a balanced distribution of grid points. Also, add the inserts wherever needed. Now let's run the grid to check the resulting mesh. After loading the grid, we can see that it is smooth and accurately captures all regions of the wind tunnel with the necessary refinement. To better visualize the grid, you can take cross-sectional sheets. Further adjustments can be made to the densities, and additional grid sweeps can be run to achieve the desired refinement in specific regions. The grid has a maximum skew of 0.76. We hope this video provided valuable insights into creating blocking and generating a high-quality mesh for the wind tunnel. If you have questions, feel free to contact support at gridpro.com. Thanks for watching.